Hello students, welcome to EPG Pathshala. I am Gaurav Gupta from Sharda University. We are going to talk on module Forecast Errors from paper Operations Management. Objective: this chapter would help students to understand two approaches to forecasting: point versus range forecast. Second, concept and methods of forecast method. Third, mean absolute deviation or MAD method, mean square of errors MSE method, and mean absolute percentage error MAP method. Last, a modern approach to forecasting accurate response technique. Objective: this chapter would help students to understand two approaches to forecasting: point versus range forecast. Second, concept and methods of forecast method. Third, mean absolute deviation or MAD method, mean square of errors MSE method, and mean absolute percentage error MAP method. Last, a modern approach to forecasting accurate response technique. Introduction: cutthroat competition in all sectors of economy, shorter product life cycles, increasing needs to develop new products faster, ever need to increase variety of products is making it more difficult for manufacturers and retailers to predict which of their goods will sell and which would not. Such phenomena also poses problems for retailers and distributors to evaluate which and how many products to order and sell. This result in occurrence of forecast errors, that is, there is increased number of happenings of substantial difference between actual and forecasted demand. This difference has been found to have significant impact in increasing cost. The difference can result in two scenarios. Firstly, manufacturer has produced or retailer has stored more products than demand, resulting in unwanted goods. These goods might become obsolete in near future, so manager intends to dispose them off at low prices or even sold at loss. Secondly, inaccurate forecast might result in loss of sales as goods are produced in lower numbers than demand. Such unpredictability of demand is quite apparent in fashion and apparel industries, food sector, various services, etc. Traditionally, inaccuracy in forecast has been addressed by companies by applying various systems such as just-in-time, inventory systems, and the like. These systems were found wanting in case of increase in volatility in demand and uncertainty from suppliers. For instance, a manufacturer can rapidly change its production schedule with change in customer demand, but would final to change the supply chain if it has already been filled with all raw material. In the industries which cater to seasonal demand like hotels, etc., sales are concentrated in few months during which manufacturers require large capacity, whereas in other months this capacity can remain unutilized. Thus, accurate forecasting becomes highly important to smoothen the capacity requirements over a long term period. Two approaches to forecasting: point versus range forecasting. Every business decision, big or small, involves prediction about future. How many people to hire, how much capacity to increase or decrease, when to launch new product are some of the decisions that are based on accurate prediction of demand. Thus, forecasting accurately becomes an important and necessary aspect of decision making for every organization. One of the most common approaches towards forecasting relies on point prediction. This approach tends to rely on predicting precisely the future. For instance, this is like asking a student how many marks he or she will score in upcoming statistics paper. It is very difficult for the student to tell the exact marks that he/she will obtain for an event which will happen in future. But most companies tend to follow this approach. They insist on asking exact amount of increase in sales next year or precise amount of profits that a subsidiary would generate. Another similar analogy is the sales target that a manager imposes on his/her subordinate. The subordinate has to achieve an exact amount of sales in limited time period. It becomes quite difficult for subordinate to achieve the same precise amount. A better approach is to forecast within a particular range. For instance, if the student says that he or she is pretty sure of getting marks between 6 and 8 out of 10 in upcoming exam, then it would be more achievable and reliable. This type of forecast is not accurate as it leaves some margin of errors as candidate can score any marks within that range, but it tends to provide more probable outcomes. The point forecast. This approach of predicting exact value or judging the best guess has following shortcomings. Point forecast approach is helpful in predicting events which are certain to happen in near future. For instance, predicting tomorrow's weather would be easy to predict based on today's weather conditions, but it would be difficult to pinpoint exactly what would be the temperature tomorrow morning. Thus, this approach should be applied to forecast for very short term periods and for those events whose outcomes are known with certainty. This approach ignores the fact that an event which is being forecasted is not a predetermined entity. The circumstances under which an event has occurred in the past might change in near future. For instance, sales of a particular type of style and color would change in near future with change in economy, fashion, trend, consumer trade, taste, etc. Thus, instead of having precise outcomes, it is better to have probability distribution for a series of events. Each probability value for each event would indicate the likelihood of occurrence of outcome. This approach ignores inherent characteristics of uncertainty in future events. If possibility of an outcome is indicated by an exact value, then the prediction is done with full confidence and no uncertainty is left. But future events would always some element of uncertainty. Thus, this approach would consider circumstances of both volatile and stable conditions as some which might prove somewhat accurate for stable market conditions but not for unstable conditions. Awareness of uncertainty is necessary for managers to prepare their businesses.
The range forecast. Range forecast, also known as confidence interval, is another approach of forecasting where a range of probable outcomes lying between the best and worst case scenario is given. Telling your superior that you will reach the office exactly at 9 in the morning is difficult to achieve than saying that you will reach office between 8:45 and 9 am. The important consideration is estimating range forecast is the size of the interval. The decided size of the interval would indicate a trade-off between accuracy and confidence. If the goal is only of being confident, then predicting that sales would be between 0 and infinite would be correct. This range would certainly include true value, but it would not be at all helpful for the managers as it does not provide any relevant information.
The range forecast. On the other hand, an accurate value of sales forecast, say number of units that would be sold next year is 1000, would provide precise information but might not be achieved with full confidence. To counter the negatives of both cases, researchers tend to follow confidence interval approach with the size of interval to be precise as possible. Sales would increase by 10 to 12% is more informative and accurate than the remark that sales would increase by 5 to 20%. Hence, a manager, while forecasting, must make a trade off between being informative by narrowing the range included in interval and being accurate by increasing the likelihood that the confidence interval would include true value of making it wider. This trade off is often difficult if not impossible to achieve.
Quantitative methods of calculating forecast errors. Forecast error is the difference between forecasted data and actual data. Higher the forecast error, less accurate would be the forecasting technique used. The forecast error values can be positive or negative. Positive values would mean that actual demand was more than forecasted value, which might result in loss of customer as demand for all customer is not satisfied. Negative forecast error values would indicate that actual demand was lower than forecasted value, which would result in increase of inventory. Thus, accuracy of forecasting technique becomes paramount as higher forecast error could have harmful effect on a company's operations. Mean absolute deviation. To obtain mean absolute deviation of given data, following steps should be followed. Calculate forecast errors, that is, find difference between forecast and actual data. Take an absolute or forecast error Consider positive of even those forecast error values which are negative. Find the average of these absolute values. Mean square of errors. To obtain MSE of given data, following steps should be followed. First, calculate forecast errors, that is, find difference between forecast and actual data. Step 2. Take square of each forecast error value. Find the average of these squared values. Mean absolute percent error. To obtain mean absolute percent error of given data, following steps should be followed. Step 1. Calculate forecast errors, that is, find difference between forecast and actual data. Take an absolute of forecast error, that is, consider positive of even those forecast error values which are negative. Divide each absolute value by actual demand value and multiply it by 100 and get data in percentage terms. Find average of these calculated percentage values. The computation of methods of forecast error has been illustrated in the following example. Data in table pertains to actual and forecast demand for 10 time periods in the past. Compute the measure of forecast accuracy. Time period 1, actual demand 120, forecast demand 109. Time period 2, actual demand 114, forecast demand 118. 3, actual demand 130, forecast demand 132. 4, actual demand 124, forecast demand 110. 5, actual demand 97, forecast demand 110. 6, actual demand 95, forecast demand 105. 7, actual demand 100, forecast demand 98. 8, actual demand 110, forecast demand 95. 9, actual demand 109, forecast demand 104. 10, actual demand 123, forecast demand 110. Solution. You have to make the table time, demand, forecast, D minus F, absolute value of D minus F, D minus F into D minus F, percentage equal to D minus F upon D into 100. Thus, mean absolute deviation equal to 89 upon 10 equal to 8.9. Mean secure error equal to 1029 upon 10 equal to 102.9. Mean absolute percent error equal to 80.22 upon 10 equal to 8.022. As can be seen from result, MSC value would always be greater as it compounds the error by square value. MAP or mean absolute percent error is a useful method if objective is to understand error in relative terms. MAP can be used to compare forecasting method in relative sense and then inference can be drawn. For instance, in this example, MAP is inferred as that there is an error of approximately 8 units out of 100. So when this is compared with some other forecasting method, then both value of MAP would be compared at same standard value of 100. This provide much clearer picture than other method. MAD is the most commonly method used for forecasting accuracy of a forecasting technique. This method takes into account contribution of each forecast error value and presents clearly any significant change in data over a particular time period.
Application of forecast error methods. Previous sections have discussed three different methods of finding errors in forecasting. This section would focus on discussing application of these methods by illustrating two examples. First example discuss which exponential smoothing coefficient would give more accurate forecast result by finding errors of two methods. Second example discusses which forecasting method is better to predict forecast results by using a particular forecast error methods.
Example: estimate demand for following data by using exponential smoothing method. Use alpha as 0.20 and 0.50 and suggest which alpha would provide more forecast accuracy. Time period 1: demand 65, 280, 390, 400, 510, 690, 775, 855, 950, 1060, 1150, 1245. So solution will consist of time period, demand, forecast error, that is D minus F, alpha equal to 0.20, absolute value of forecast error, forecast error, alpha is equal to 0.5, absolute value of forecast error. So the table will be made and the totaling will be done. MAD with alpha equal to 0.20 equal to 221.53 divided by 12 equal to 20.13. MAD with alpha equal to 0.50 equal to 171.29 equal to 15.56. Sum of the above results, it can be interpreted that MAD is less when smoothing coefficient of 0.50 is used. Thus, smoothing coefficient of 50% should be used for forecasting purpose in this case as compared to 20%. Example: following data gives actual demand for an item for a 9-month period. Test two forecasting methods to see which method was better over this period. Forecasting April through September using 3-month moving average. Use exponential smoothing with an alpha of 0.3 to estimate April through September. Use MAD to decide which method produced better forecast over 6-month period. And the chart is drawn where attributes are month, actual, 3-month moving average, error, exponential smoothing, then error. Forecast error by using MAD for 3-month moving average is equal to 23.33. Forecast error by using MAD for exponential smoothing method is equal to 6.52. As forecast error calculated by using MAD for exponential smoothing method of forecasting is less than forecasting error by using 3-month moving average method. So it can be inferred that exponential method should be used for forecasting purposes. Accurate response, a modern approach to reduce forecasting error. Demand uncertainty. Most companies fail to incorporate uncertainty in demand of various products that they are manufacturing into their production schedule, resulting in inaccurate forecast. They base production planning on forecasts which are made far in advance of selling season. For instance, toy manufacturer forecast demand for toys far in advance of selling season, which is during festive season of a month or so. This is done to provide them ample time for production during lean season. But when time comes for selling festive season, there could be a scenario that demand changes and product becomes obsolete. This would cause huge stocks of unwanted goods. The failure of incorporate demand uncertainty happens for following two reasons. Companies fail to factor multiple demand scenarios into initial forecast. Demand can vary because of various reasons, and if at all these reasons are not accounted for, then it would result in inaccurate forecast. Secondly, frequent change in consumer buying patterns. This would force companies to introduce new or variants to existing products. Flexible manufacturing systems and processes to produce small at low prices have facilitated in fulfilling varying demand of customers. But this has also resulted in certain side effects. For one, such frequent introductions reduce the average lifetime of products. Some of them die at introduction stage and some of them reached decline stage quite quickly. For instance, mobile phones have very small life cycles because of competition, causing companies to launch new models very frequently. Similar scenario can be seen in case of automobiles. Also, as products proliferate, companies indulge in forecasting for entire product line rather than forecasting for each variety of products. Such aggregate demand is easier to predict, but forecast distribution among products which would give more accurate result is difficult. For instance, a soap manufacturer, if is producing 10 variants of soap, then the manager can forecast for all 10 soaps in totally or for each soap differently. Aggregate approach would provide a sales forecast for all soaps, but it would fail to indicate which soap are less in demand and which are high in demand. Such approach would cause company to manufacture all soaps in equal quantity. Whereas if forecasting is done individually, then it would be much clearer that which soaps should be manufactured in lesser numbers and which in higher numbers. Following cases illustrate such problems. Case 1. Retailers are exercising more power with suppliers in ordering of various products. A retailer selling toys would store toys only at the time of selling and would not store much before selling period, resulting in shorter lead time. Also, the retailer formulated a policy to purchase toys depending on customer reaction. Earlier, supplier expected to supply consignments of toys to the retailer's distribution center and get paid. Now, payment is deferred till actual sale has been made. Remaining toys would be sent back to manufacturer. This has made manufacturer to apply better forecasting methods so as to reduce building of unwanted goods. Case 2. Usage of tools such as customized screwdrivers, drill, etc. as gift items were found to be new phenomena by a retail manager. It was also observed that customers want these items to be in attractive packages and in small sizes. Manufacturer had facilities to produce such tools in bigger sizes and less in number. So to fulfill new orders pertaining to change in customer taste, the manager has to change its production planning. Proper forecasting would have mitigated such problem in production. Case 3. A car company like General Motors, Ford or Maruti Suzuki is involved in manufacturing variety of cars from SUV to small cars. Demand for small cars was found to be much more than bigger sedans or SUVs. In case of Maruti's small car, which was manufactured in both petrol and diesel variants, it became imperative for company to forecast for each variant of small car and for each segment. Aggregate forecasting approach would result in forecasting for all cars irrespective of segment and variant. This would cause faulty forecast without indicating demand for each type of car. Accurate response, the technique. Accurate response has been suggested as Another approach by manufacturers and retailers alike in reducing forecast errors. The technique was found to be quite appropriate in redesigning planning processes and minimizing inaccuracy in forecasts. It helps in figuring out what forecasters can and cannot predict well, making the supply chain more flexible and responsive so that manager can postpone their decision to buy raw material and produce for unpredictable items until they obtain some market signals regarding their demand. This approach incorporates two basic elements which were absent in other traditional methods of forecasting. It considers missed sale opportunities. Forecasting error result in either too low or too high inventory. The technique of accurate response measures the cost of each unit in case of low and high inventory. These costs are then incorporated into the planning process. Many companies misses this aspect of sales lost and cost incurred on each lost sale. The technique distinguishes demand for the products which are predictable and which are unpredictable. The items which have predictable demand can be produced much before sale season, and then those free resources can be used to produce items which unpredictable demand which becomes known close to sale season. Such knowledge helps companies to reconstruct and reconfigure their supply chains in terms of selection of vendors, transportation and location decision, and number of warehouses. It also encourages company to redesign the products so as to meet changing needs with least disruption to production facilities. These two aspects of flexible manufacturing and shorter cycle times evaluated by accurate response technique are incorporated in planning processes which ultimately helps in accuracy of forecasting. Companies which make or sell products with stable demand and long cycle times can use traditional methods of forecasting which would prove to be quite accurate. But accurate response technique is quite useful to reduce forecast error for companies which make or sell products with short lifetime and volatile demand.
Let us summarize this module. Two approaches to forecasting, namely point forecast and range forecast, has been discussed. Point forecast provides confidence to forecast but tends to be inaccurate most of the time, as an exact value prediction is near impossible to achieve with change in circumstances. On the other hand, range forecast provide accuracy to forecast as true value has high likelihood of falling in the given range but lacks confidence in prediction. Also, challenge to this approach is selection of size of interval. Different methods of evaluating forecast accuracy have been discussed. Mean absolute deviation, mean square of error, and mean absolute percentage error has been discussed with illustrations. These methods can be applied to find which of discussed method of forecasting helps in predicting more accurately. Also, a modern approach to forecasting, namely accurate response technique, has been discussed to emphasize the importance of flexibility in supply chain and modification in design of products. A case study illustrated the application of this approach.